Okay, so what we're going to make this morning is a set of these bars. Just going to show you what goes into a set of cheesy bars. Now, these ones are not slotted for wiring, but we'll be doing internal wiring in the other one. So I'm going to show you guys how I do that. So obviously the first step is to cut your material. Now the material I use is this heavy wall stainless. It's a 304. And the second step that I do is machine the ends down on the lathe. Do some notching. So what I do as a bit of a hack is I measure exactly half in that bar. So these bars I'm making are 10-inch rise. Now what I've done, because I'm going to take an inch out of the middle with a hole saw, is I've measured 21 inches. So see, we've got the halfway here. Now here's a set that I've done earlier. And we're getting a pretty nice cope there. That's obviously pre-cleaning, but I'll show you how I do that. So the machine that I do this process on is the old Anayak mill. So the first step will be to do a pilot hole. Now the way I clamp it just in some soft jaws, and then I put one of these little ladder supports there just to support the outside of the bar. So I'm going to use a little bit of RTD. Just got a shitty old drill bit in that. Being such heavy wall stainless, it can be a little bit of a bitch to machine. It work hardens really easily. So kind of want to have sharp tools. That's our pilot hole done. Now I'm sure someone's going to say, oh, you should do it with an abrasive method or something like that, but the reason I do use these hole saws is because I get them quite cheap. They're a Sutton hole saw. Okay, so we've got a fairly slow speed for the stainless, had a bit of cutting fluid, and the pilot hole should stop it wandering around too much. Just run a bit more speed, just to get into the first bit, and then I'll back it off a little bit, speed wise. And yep, that tool is getting hot, so I want to add a little bit more RTD. Some coolant would be nice. And I'd probably get a longer life out of the bits, but as you can see, we're already halfway. Now, it's 1-inch material, and I'm using a 25mm hole saw. That's why it's slightly undersized, but it's a nice way to do it. Because the hole saw will cut slightly over 25mm anyway, so it'll be perfect for the 1-inch material. Alright, we're about to come through down the bottom now. And that's that. So I've done 5 holes, and as you can see, I've got enough for 10 riser legs for a set of bars. Now that is pre-cleaning up, and as you can see, that's a really nice notch. A little bit sander. So guys, because these are getting internally wired, we're going to see that little edge there. We're going to deburr all that quickly, just with the old tungsten carbide burr. Next comes the welding part. Now, this is for the threaded bung in the bottom. So I used to machine these up myself, but they actually take too much time. So I get an engineering mob down the road to make them. So they're a 1/2 inch UNC thread, stainless steel bung with a nice step on it. Okay, so we're on to welding up the bungs. Now, you can see there, we've got a nice consistent kind of bead action. Now I'll show you guys how I achieve that. So I've got my welder set up here, running on 45 amps, and I have my earth lead running into my lathe, through the back of the lathe, through a copper rod, down to the bar. Now the reason for this is, you've obviously got to earth out the material, but if we clamp that on anywhere else, it's going to be arcing through the gears, and then that is going to fuck our gears up. So the copper rod actually will just obviously be the path of least resistance for the current to flow down to this piece here. Now I'm running the lathe off a VFD, which I've got, which is variable frequency controller or device or something, I don't know. And then I'm running it through the gearing. So on the lowest VFD setting, that's my forward and reverse, I'll run it in reverse through this second lowest gearing set, through the back gearing. That gives me this RPM, whatever RPM that is. It could be 1 RPM, 1 whole revolution per minute. I don't know, I haven't timed it. You guys can work it out if you like. And so I'm gonna weld it up, so using the lathe as a welding rotator or a welding positioner. It's a bit of a time saver really, and it helps get a nice consistent result. So here we can see that has given us a nice and consistent result. It's still not what I would call 100% perfect. I'd say it's 95%. Okay guys, so the next step I'd like to do is basically clean them up, get rid of the discoloration there. So back in the lathe on a high speed setting, VFD, run all the way up. I don't know, I was running maybe 1800 RPM there, and I've just got some Scotch-Brite pad, so I'm just going to give them every one of these set of risers just a little brush. The material already comes brushed, but just when you store the material, you know, you might get a few nicks and scratches on it. You can see there that the discoloration is going away. It's giving us a nice kind of satin kind of. So here's one that's been cleaned up, first one that hasn't, and you can see it's got a much nicer luster. Any of those little nicks and stuff are gone, and our weld looks nice and consistent. To make the top T-piece. So here's one I prepared earlier. Machine the ends so that way once it's bent we've got some nice machined ends on there, and then I'll measure the halfway point and then the start of where I want my bend. And I'm going for about 30 degrees pullback on these because that is what I find is the sweet spot. The bender being used is the Speedworks Model 2, and I've got the 1-inch die in there with a 3-inch center line. So let's bend away. We need some little slots here and here. I like to offset them just to the back a bit so that they can't be seen from the front. So I've got this precision marking jig. I've lined the bars up so that the cope is parallel to the bar, and I'm just going to mark that there. There we've got our little mark that we just put on there, and I'm going to line that up with the pilot drill. So that mark has allowed me to clock the cope so it's about 30 degrees off axis. So we don't want our slot to interfere with the bung, and if I measure there, 47 mils from the bottom is what we're going to aim for. So on the DRO, we're going to set that point there as 0. And then we're going to move across. Until that gets to 47. So line that there to 47. And that's our distance there. For the lower that's our first hole, and we're going to move it up to 57. Alright, that's near enough. So what I'm doing is I'm removing a lot of the material so that my end mill can do a few little plunge cuts, because if I take all of that material out with the end mill, it's going to ruin a more expensive tool than one of these drill bits. So take a lot of our meat out. We're going along the back face there till we get to our 57. There we go. And back across the y-axis. We're looking for a number down here, and that's 1. Now we're on this front face, and we're going to cut back to our 47, and then back across into the middle, and that's our slot. So there you can see our slot that we've made. Looks nice and neat. We've got the bung get rid of the light, but yeah, you can see it there, it's just shy, so that's the reason for that measuring. Okay, we've got our little marks line back up, and you can see there that those slots are perfectly symmetrical. And we've got our top piece, sits in there like that. We've got our center line there, so we can get it in the perfect spot. I like to then just run a texter around there, which will give you these marks here. Then that gets drilled out on the mill and deburred obviously on the inside. Still just got to give that a bit of a clean up, and then we can weld her up. So just to demonstrate something to you guys, I've strapped up the top bar on there at the approximate fork angle, so 30 degrees. Now we don't want these ones to have any drop, just because that's what the customer wants. He wants them flatter up, so basically when they're on the bike, that they're sitting flat like that. So if you see from the side there, pretty flat. Now you can see there's our texter line, so I'm going to tack it there and then make sure she's straight. I've got these tacked up, guys. I'm just going to give them a little clean with some acetone now and then mold them up. Righto guys, on to the last notch for the control. You can see they're all welded up there. So we've got slots there, then we've got some internal holes here. Now we're just doing the last little slots there. And I'm looking for 160 mil. Oops. That's going to be our first hole. That's it there. Alright guys, last bit now. I'm going to clean them up with the tube polisher, and I've got a Scotch-Brite belt on there.